Welcome to Ask and Learn.
So again, we have a block suspended from a ceiling or a base that's moving up and down, and the block is responding to that by moving itself. In this case, basically we have the exact same situation as we had in the previous problem. So our equation of motion is exactly the same, and our solution is exactly the same. Now in this case, again, we have some initial displacement and no initial velocity. So again, we take this, and again, y is measured from the equilibrium after gravity has been applied. So the initial system would look like something like this, and then the spring isn't stretched, and then we let it slowly come to rest, and it comes down to this position. So the gravity has been taken care of by some pre-stretch in the spring. So that's why it doesn't show up here. In fact, it basically just canceled out because we had ky static here and plus mg here, and that cancels with that. Now, we have, again, our natural frequency and our frequency ratio. We can get the natural frequency is 12.25 radians per second from K and M. We again know that B is Y naught, and A is minus delta naught R over 1 minus R squared. We can figure out what R is, and we can calculate this to be, this is about 3.66 millimeters. Our initial displacement was 10 millimeters. So then we get, let's see here. Oh no, this isn't our initial. This is our initial. Our initial displacement was 50 millimeters, right here. This is the amplitude of this oscillation here, and that's 10 millimeters. So we can see here that we have our homogeneous solution, which has a frequency component content of the natural frequency, and then our particular solution has a frequency content of 4 radians per second. And we can see that the amplitude here is pretty close to the amplitude here. Okay? And why that is because R here, notice you have 4 over 12 roughly. So this is like 1/3. R squared is 1/9. So we have 1 minus 1/9 is 8/9. So, this denominator is pretty darn close to 1, and that's why this is pretty close to this.